let's talk about that Yamba application that we talked about earlier, that I showed you how to run and download and all that stuff. So let's talk about its design a little bit. So first of all, a little bit about background on Yamba. So I've been doing this class for like a couple of years now, right? And I had always different apps initially. Like you need an example app, right? And initially, my example app was like, I think at one point I had a Sudoku game, then I had the restaurant app, then I had a golf app. I just came up with a bunch of different things. And I was looking for something that is I had two conditions for a perfect app, right? One was to have something that is easy to understand, that I don't need to explain what it does. Like, what does a golf app do, right? Like, you got to explain to people. So become the actual, the user stories become complex. But the second constraint was that in a very good way touches a lot of different parts of the platform. So it illustrates how things work and why they work a certain way and so on, right? So that, after a while, I figured that Yamba is this example is actually really, really good, because in a very natural way it shows a lot of different things that we want to showcase. So that's why I kind of stuck with it for a while now, and it's kind of seems to be working really well. So let me explain how I would design something like this on the back of a napkin, right? So I'm gonna use this. I developed sort of like a little, just symbols and stuff. I guess the language, graphical language. So basically, this is a activity. It's drawn like this. Kind of looks like a screen, right, on an older phone. And then this corresponds to our application context, our application. So this is our application, the dotted line. Make sense? So the first iteration of this application, we basically build a status activity. That is this screen where you get to say what you would like to have done, or sorry, what your status is, right? So this is the screen, status update. Make sense? It's a world simplest screen. You type in something, click on update, bam, it posts, does a web service call, and posts it to Twitter, right? So that's first iteration. And by the way, each iteration corresponds to the actual chapter in a book, right? So this is chapter 6 is this iteration. And chapter 7 is the next iteration and so forth, right? And also it corresponds to the source code. So Yamba 1 that you guys have, right, here is going to be that. So that's going to be Yamba 1, 2, 3, and so on, right? Make sense? Cool. So second iteration, we figured out that in the first iteration, username and password were hard-coded. There wasn't really a good way to specify username and password. Well, that doesn't make your app very useful. Like, you can't charge more than, like, I don't know, 19 cents for it or something, right? So, if you want to jack up that price, you gotta have users be able to configure username and password. So you basically add another activity that now uses a file to store this password. So this guy saves to that file, this guy reads from that file. Make sense? Third iteration. We basically now write a service. This service is doing the pull. Every so often goes and checks the internet and says, is there something new? Is there something new? Is there something new? Right? Does that. It's very, very boring life of a service. Just goes every frequently and does a pull, right? Because we don't have a push. We don't really have to wait to say, hey, why don't you just let me know when there's something new in this mechanism. There is actually a way to do it, and we did it, but it's using something called C2DM, Cloud to Device Messaging. different ballgame. So at the end of this iteration, it is whole and complete. The user can't see the data, but we can see in the log that it's actually the data we're getting the data and everything's good, right? We're not rendering it for user. So the next iteration is we now add this data to a database. We create a database and we now store this data in a database. Okay. We cannot verify the data is in the database. We don't have a way to view it. The user doesn't, but we can verify that it's there. So we are whole and complete, right? So for fifth iteration, we finally add our final and arguably most important activity, where you get to see what your friends are doing, right? You get to see, you know, the timeline. Okay. By the way, why didn't we do this? Every time you switch away from it, you lose the data. Okay, that's one reason. Any other suggestions? Mm-hmm. You would, yeah, it'd be making it slower. So it's in other words, you would be dealing with latency, right? So every time I open up my activity, I would have to wait for it to pull the data, right? Right. Another reason why this is relatively bad is it wouldn't work when I'm offline. And usually, you know, when I got time to read my tweets, is I'm on a subway or flying somewhere or something, right? Right. So essentially, doing something like this, it shows you the difference between a web app and like an Android native app, right? On a web app, this is how normally it would work, right? On an Android app, we can actually do these things. Like this is something that you cannot I mean, don't get me wrong, HTML5, I know you got web workers, you know, so something like this could do a web working stuff. Something like this could be offline storage, but it's not really meant for all that, right? It's very lightweight kind of stuff, right? So, but in Android you can, and it's designed for exactly this kind of more complex architectures, right? So, this also illustrates why we would actually have the database. Oops, hold on 1 second. Why we would have the database on a tiny device like this? What's the point of a database on a plastic little thingy that you can easily lose or it gets stolen or something like that, right? The good reason for a database is merely to be a cache, right? These databases, I couldn't care less. Blow it up, right? That's fine. We just go and pull the data again from the online storage, right? So that's what you typically use databases on a mobile device to begin with, right? So, and by the way, one thing that I didn't explain in one of these iterations here, what we did is. You know, this guy needs a logic to connect to Twitter and pull the data. This guy needs a logic to connect to a Twitter and post the data, the update, right? So I figured, wouldn't it be better to actually move that logic into some common placeholder, right? And there is a object that's readily available to everyone within the application context, right? That's called application. So we actually hang some common functionality off of this object called application. Common Java objects. Common state stuff. So that's what that is. Right? So we use it as to refactor some of the code into there. Okay. So that's Yamba 3. And this is Yamba 5, right? So one thing that I realized in Yamba 6 is that this thing here, the update service, right? We want it to be always on, always running. Like I don't want to have to remember to start my. You saw how many I have? What, a dozen different services on my regular phone? Like imagine every time I reboot it, I have to remember to start Facebook update, Twitter update, Google Mail update, blah update, and so on and so on. Like, that would be a really annoying user experience. But rather, you'd like it to be always on, always running. So one way to do that is to basically say, look, I'm gonna write a little receiver that's going to get notified from the system, right, when there's a new update. Well, sorry, when the system is booted up. And then it's simply gonna go and launch this activity, this service, right? It's my boot receiver. It's like a couple of lines of code, the whole thing, right? So the other receiver here, this guy wants to get notified when the network is up or down, right? Like if I'm flying somewhere, I'm up, you know, I can't connect to the cloud, not to the real the cloud, Twitter cloud, right? So, you know, I forget to turn off your phone while flying or something like that, right? So it's not gonna get a connection, right? It's not to the right cloud. So what you want to do is you want this guy to basically stop your service, so it's not keep on trying. It doesn't keep on trying, because if it keeps on trying, it's gonna waste your battery really quickly because the radio is trying to get a connection to the internet.
I think we have a lot of flapping between this.
What do you mean?
The boot receiver starts your data service. Network receiver. What's it done?
Yeah, it could shut it down, then restart. So yeah, so this guy, we can actually obsolete this guy. I mean, this guy could do both, right? But basically, this guy is gonna start it, stop it as the network becomes available, non-available. So yeah, that's exactly what we want. Yeah, because if I don't have internet, I should not be trying to start a, or yeah, I should not be checking the using the radio. Right? Like, radio is one of the most expensive things you could be doing on a phone. It's like a second most expensive thing, right? Because every time you fire up a radio, your battery consumption goes up about tenfold. Goes from 10 microamperes or whatever to 110, something like that. Depends on the model, but it's pretty high.
Especially 4G.
Yeah, especially 4G. Yeah. So that's why you're getting these new phones with like bigger batteries and all that, but they just last shorter and shorter time. And then CPU also uses more memory. They now make, is it NVIDIA? That's the new 5-core? 5-core.
4-core plus 1 small core.
Yeah, so they have sort of like a 5th core, which is for tiny tasks, because the big 4 cores are an overkill in terms of the battery consumption.
So really, GPU is the most before CPU.
Yeah, GPUs. Yeah. So yeah. So those are the kinds of things that we worry about mobile, but we don't care about we don't care about this on these things, right? Usually on regular desktops. So yeah. So that's where broadcast receivers become handy. Just to mix things up, what I did is I added a broadcast receiver here, but I used in a different way. It says timeline receiver. So these two illustrate how you get subscribed to a message from a system, from another, from some outside world. But what if I wanted to notify one part of the system, send a message from one part of the system to another, right? For example, timeline activity. Remember, timeline activity is this guy. It's where you're like basically seeing what your friends are doing, right? And if I'm staring at this screen and I'm waiting for a message. I'm staring and waiting for a message. Now, what might have happened is our pull cycle happened, right? Our pull cycle happened. We actually did pull that new message. We actually stuffed that new message in a database. Okay? But this guy doesn't know that. He doesn't know that it needs to re-query the database. How do you tell it? How do you send it a message? Well, one way is to create a timeline receiver here, which I drew kind of like this because it's not statically registered via manifest file, but it's dynamically registered just while this activity is in a running state. So this guy only exists while timeline activity is in user space, right? So what happens is this guy, when it's got a new tweet or new message, it's broadcasts that, this guy receives it if it's registered, and then refreshes the screen. That's the goal. So it illustrates a different way of using a broadcast receiver, and it also illustrates how you can send a broadcast from one part of the system to another, one part of the application to another, right? So far, so good?
Okay, so that part of and then the timeline activity would query the status state. Once it receives the message as a broadcast receiver from the updater service.
When it receives the message,
so the updater service notifies of the new statuses. It just notifies it.
Yeah.
And then the timeline activity actually goes to status data and pulls up the.
Exactly. Yes. Yeah.
Okay.
This serves just this is just the tickle, right?
Yeah.
It says, "Go do something."
Go do something.
Yeah. So he wakes up this guy, and then that guy goes and does something. So that's basically, if you remember in broadcast receiver, it's gonna wake up this code, whatever that code now does. Presumably, it requires the database. Yeah. The final part, part 7, was basically I wanted to create an app widget. App widgets are things that you can put on a home screen. You know, I'm talking about the little, well, here. You know, here we have the little, you know, this would be a little widget, right? The clock. Yeah. You may have a widget, like on my phone I have my calendar, what's my next event that's coming up or something like that, right? So those are called app widgets, not to be confused with widgets that are UI elements. Well, I wanted to basically create something like that, and well, I did it, but then I realized, hey, this app widget actually doesn't run in our app. You create it as part of your app, but it actually gets executed as a remote something something by the home screen. So it's a remote view, right? So if it's something that's remote, to get data, you need to expose the data. It can't just magically open up the database and connect to it. So that's a good motivation to basically create this status provider, to expose the data. You cannot get to your database because you don't have permission, because it's running in a separate process. So this is going to be a process called home screen. Yeah, so the receiver is kickstarted because the receiver is registered to be kickstarted. So when you install the app, so that install time, you register it for that update. You say, I want to know forever and ever when the system boots up. And that's done via the intent filter in your manifest file. Those things are analyzed statically at install time. So that's true for the manifest file. This one, like I said, just to mix things up, the timeline receiver is registered dynamically because I only wanted to register it while user is staring at that screen. So it goes register, down, register, register, down, register. Very different usage. Yeah, so the question is, why didn't I go for status activity or timeline activity? Why didn't I go this way? Also, you know, yeah, so status activity, yeah. Not status activity, but timeline activity. So why not just go this way, right? And then have it use the status data. You could do that, but like I said, a status provider is a level of abstraction that has a certain cost. It's actually, I don't know, it's probably the least fun to write status providers. Right? So to me, they're not as fun at all. I think there's just like a lot of kind of code that shouldn't be there. So there's no reason to provide for separation of concerns if everything is part of the application sometimes. Yeah, but you could. So it becomes a design decision. So.